All right, so it's my finals week, so I'm going to try to quickly crank this one out if I can. So here we have this grid, and basically we're just trying to find the distance between all of the 2 points in Manhattan distance, which is pretty easy. And then we want to sum all of these together. The only difference is we have to expand these rows. Basically, any column or row that has nothing in it, we have to expand. So first of all, let's just go ahead and parse our input. So the way we're going to do this is we're going to just save all of our raw points first. So, and we're also going to find out like how big this can be. If I looked at my input in the test and it seems like it was a square and all the points were used, so I'll just do len input dot split lines. So here we're getting this, or we're getting the kind of size, and then from this I want to create a list of all the empty spaces. And the way I'm going to do this is for each point I'm going to remove it from the set. So I'll create a set of range lim and another set of ranged lim. So I have two different sets that are currently filled with every single point in the area, and this one's going to be for my x, this one's going to be for my y. Now let me go ahead and iterate over this stuff. So for y, making line for y l in enumerate for the line input dot split lines, for x value in enumerate over my line. Then if v is equal to this hash symbol, raw dot append, and at the top I made a complex points again. So we'll do this. And then also empty, so the x value should get removed from the empty for the x. And then for this, let's go ahead and remove it for the y. All right, so now let's go ahead and just print this out. And we should be able to see, or let's print out our empty. And so if I run this on the test case, you can see that the empty rows are 2, 5, and 8 for the x. If I look here, 0, 1, here, 0, 1, 2, 3, 4, 5, 6, 7, 8. That looks good. And then for y, we have 3 and 7, and that looks about right here. So cool. We're going to assume that we read it correctly. So let's now go back and keep going. All right. So now let's go ahead and call this in a solve function. Raw empty true. And here, foresight, I've already done this question. I'm looking at my code. But here, we'll create this function. And later we'll get to this whole thing. All right. So what I'm doing here is I'm basically defining how many extra lines I should be adding. Spoiler, this is part 2, but let's go ahead and create our new grid. This will basically be our augmented grid where we already expand all for space. So for this, we're going to go through every point in our raw data. And then first of all, we're going to want to basically go through all of these empty coordinates below it and then add that to it. So let's go ahead and make our, just make this a little bit more readable. I'm going to create a new variable, which is going to be how much I'm modifying my point by, and it's going to be equal to basically this new point, which is going to be the sum, and this is going to be a list comprehension. So something, I'll just type it for a and empty 0, and then we'll also have one for this match. All right. So what this is doing is basically we're going for every element inside of the empty list. So we're seeing all of the empty points that we have. And if it is less than the current point that we're at, we'll sum it up. So we'll get all of, basically, this will return how many empty rows there are in the x value that are before our current value. And the same for the y value. And then real and imaginary is how we're kind of using complex numbers. But so now, from this, we have this point. We'll go ahead and for now we'll just leave it like this, or I'm just going to go ahead and do this. We'll multiply it by this factor, and then finally we're going to add to our grid this point plus this new modifier. And then now answer is equal to 0, and then for I in range here, and then we're going to iterate over all of this stuff. So for I in range len grid -1, and for j in range len grid, and we want to start at our I plus 1. So what I'm doing here is I'm basically iterating. So if I have like a list of 10 elements, this is going to iterate through these, like all 10, or up till 9. And then this is basically going to iterate from that point onwards. So this is going to give me all of the unique pairs. So if I just go ahead and run this, sorry. If I run this, you'll basically see, and like if you print this out in your code, you'll basically see no pair gets repeated twice, because I'm basically iterating only, the first value is always going to be less than the other one, and then we don't have any duplicates that way. All right, so now for each of these, we have our answer is 0, and we'll go ahead and return this answer also here. And then our answer should be increased by the distance between these 2 points. And you can go ahead and prove to yourself this, but right now I'm just going to write it down. We're basically going to just do the int, and we're going to do the Manhattan distance between these 2 points. So that's the same as the difference between the x and the difference between the y. And that can be found through, here, I'm going to create this as a function. So get dist, grid I, grid j. And then now if I create this as a function, def get dist, ab, return int, and then absolute value here plus absolute value here. And this is going to be a dot imag minus b dot imag. And it doesn't really matter the order. A dot real minus b dot real. All right, so now if I go ahead and run this on the test case, let's see what we get. 374. If I look here, we should be getting 374. Perfect. And if I go ahead and submit this for my code, so here, we can see that I get the right answer. Now for part 2, instead of just doubling every row, we should increase it by 1,000,000. And so now all I have to do here is, I'll change this to factor 1, if part 1, else we're going to set it equal to some other value. And so just because I've already done this, let's look at this example where they say if it was only 10 times larger, here, if it was 10 times larger, it would be this value. If I set this value to 10, notice how we end up with a larger value than what we should be getting, except for the fact that I never actually added this here. So solve raw empty false for not part 1. Notice how we get a larger value. If I subtract 1 from this value, we end up getting the right value. And then if we look at the test case, the second one, just a sanity check, 100 times larger, 8410. I'll put this to 100 here. 8410. Perfect. And so basically the whole reason why is because if we're doubling it, we had 1 less because we already counted for that. And so here, we want this to be 1,000,000 minus 1. If I run this on the test case, we end up with some value. And then if I end up submitting, we get the right answer. So yeah, I'm going to kind of be rushed for the next few days because my finals are here and I'm underprepared. But yeah, hopefully this was good. Good luck.